It's okay.
I couldn't even.
Ross, dx or dy integral? 50-50 shot.
I think it's dy.
Okay, you think it's dy. Why? Why do you think it's dy?
It's moving up and down. Wash.
All right. Well, here's the question. If you were going to do washers,
It's dx because it's shell method.
no, it's not. At least you gave me a reason. If we were going to do washers, how would you draw them? Because this region has to come around like this. So if it was a washer method, would it be a dx or dy?
dy.
Okay, let's draw what a washer would look like. That's a washer, right? And those washers are going to be sliding left and right. So these washers are dx, which tells you that the shell will be a dy integral.
I knew it.
Yeah, I didn't say you're wrong. So let's draw a cross. So once you can figure that out, draw your cross section. There's a random cross section across the y-axis. Looks like that. Let's do that again. Here we go. Okay. Do we see our shell? Our cylinder? You guys stop, please. Thank you. There's our cylinder. That's going to be sliding along the y-axis. So it's going to start at 0, and it's going to slide to what? From 0 to 1. Okay, then we have 2 pi RH. Now it's going to get a little tricky here, so we really want to focus, pay attention to what's going to happen. So 2 pi integral from 0 to 1, a dy. We got to figure out what our radius is. Okay, so Paul, you got an idea?
Y plus 1.
1 plus 1?
Y plus 1.
Y plus 1, okay. So here's our radius. That's the radius of the cylinder. So this distance right here is y, as Paul said. And this distance is 1. Right? Does that make sense to everyone? And it's a dy integral, so we'll just do 1 plus y. Now we got to figure out our height. The height is that distance, h. Well, not that whole distance. From here to here. That is h. So, Jacob, what do you think?
2 root y.
Yeah, so how do you figure that out?
Because
What's this piece?
that's root y.
Right, it's usually, when we think of it as x, but in terms of y, you solve for x, you get the square root of y. But there's 2 pieces to incorporate the entire height. So it's going to be 2 times the square root of y. Did we blow anybody away there? Okay, so the radius or the height? The height? The height is this distance. This is the height of my cylinder, right? Because the cylinder goes like this. Here's the height. Well, here's the y-axis. This distance is x. So you go from the y-axis x units to your curve. But your height is the whole thing. So x units to the right, x units to the left. That's a total of 2x units. But x is equal to the square root of y. So you write 2 root y. Yeah, Ross?
Can you explain the radius?
The radius, yeah. The radius, so we're revolving, the radius always starts wherever you're revolving from, or revolving around. I'm revolving around the line y equals -1. So I start here, and I go to my cross section. Well, from here to the x-axis, that's going to be 1. So that's where the 1 comes from. And then we got to add the height of my function. So my function changes as x changes. Right? And that height is the y-coordinate. And since I want it as a dy integral, we just say y. If there was a dx integral, I'd have 1 plus x squared. Because x squared is my height also. Right? So you just pick whichever one you need for the integral to make sense. So since it's dy integral, you just write y. You guys got it? Hopefully? Okay, so let's go. We just solve.